For this question, roughly 1/3 of candidates gave no response to part B, and more than half gave no response to part C, which means that the majority of people missed out on 13% of the paper, contributing to a weak overall performance with a mean mark of 22.6 out of 75 and a quarter of candidates getting a U. Today, we're going to be going through each section step by step to prevent you failing the question and prevent the chances of you failing the paper altogether. Part A is pretty standard, and this was reflected by the fact that in the exam report, it states that the majority of candidates attempted the question. To be fair, this question is quite easy. To show that x plus 3 is a factor of p of x, you simply need to prove that p of -3 is equal to 0, as you'll recall from the videos on the factor theorem previously. And so, if we plug in -3, we get -3 squared plus 5 times -3 squared plus 31 times -3 plus 75, which equals -27 plus 45 minus 93 plus 75, which gives us 0. Therefore, as p of -3 equals 0, x plus 3 is then clearly a factor. Now, this is a section that roughly 1/3 of people failed to answer. This is a shame because it's actually very easy. All that's changed from question 1 is that instead of x as the variable, we now have z as the variable. To show that -1 plus 2 root 6i is a root of p of z equals 0, all we have to do is literally plug it into our new equation, z cubed plus 5z squared plus 31z plus 75. So then, to solve this question, we will start off by saying z squared equals -1 plus 2 root 6i squared altogether, which equals then 1 plus 24i squared minus 4 root 6i. And when we expand that, we get 1 minus 24 minus 4 root 6i, which then gives me -23 minus 4 root 6i. Similarly, z cubed is equal to -23 minus 4 root 6i times -21 plus 2 root 6i, which then gives me 23 minus 46 root 6i plus 4 root 6i plus 8 root 6, which then gives me 23 plus 8 root 6 minus 42 root 6i. Here's the simple part. Simply plug this into the equation now, and what you'll notice is that when we do that, we get 0, as you can see, which indicates that -1 plus 2 root 6i is a root. This is by far the most difficult section, since over 50% of people could not get the answer to it. We must first recognize what is asked of us. That is, to find the complex numbers, which are the roots of p of z squared equals 0. But, to get the complex numbers of p of z squared, we must first ask, what even is z squared? Remember that from the previous section we had 2 roots, -3 and -1 plus 2 root 6i. Therefore, we can set z squared to both of these. Also keep in mind that they want z, not z squared. This sounds glaringly obvious, but it's important to keep this in your mind when structuring your working out. Linking to this, we can say then that if z squared is equal to minus 3, z must equal plus minus root 3i, which gives us z1 is equal to root 3i and z2 is equal to negative root 3i. Now, this is the part where you must focus harder, because finding the root of negative 1 plus 2 root 6i requires a few more steps. The key for this one is to remember that negative 1 plus 2 root 6i is z squared, which means that there is another complex number that we don't know yet, that when squared gives us a negative 1 plus 2 root 6i. As we don't know the nature of this number, we can just call it x plus iy. So therefore, x plus iy squared must equal negative 1 plus 2 root 6i. The situation we find ourselves in now is that we have x and y as unknowns, which means we'll have to find these next. The way to do this is to recognize that we actually have two components to the equation here. One that equates the real components,
Real?
and one that equates the imaginary components.
Imaginary.
As a result, we get x squared minus y squared equals 1, and 2xy is equal to 2 root 6, which means xy equals root 6. So therefore y is equal to root 6 over x, which means y squared is equal to 6 over x squared. This means that we're able to get an equation in terms of x. X to the power 4 minus x squared minus 6 equals 0, which when solved gives us x squared is equal to negative 3, and x squared is equal to 2. From here, it's just a case of solving for x and y. So x is equal to plus minus root 2, and y is equal to root 6 over x, which is plus minus root 3. So then, our solution is plus minus root 2, plus minus root 3i, which gives us 4 iterations as answers, and when coupled with the value of z1 and z2, gives us 6 values for z in total.